Grade 5 Math, Topic 16, Lesson 2. What are some properties of quadrilaterals? In this lesson, I want to review some terms before we dive into classifying the quadrilaterals. Remember, anytime you see this box in a shape, it's going to represent 90 degrees and it's going to be a right angle. I want to talk about the difference between the angles in quadrilaterals and triangles just to give you a little bit more information of why they have 4 angles and they don't total the same thing as triangles, so we don't classify them the same way. To review from yesterday, we would add angle 1 plus angle 2 plus angle 3, which would give us a total of 180 degrees that the triangle's angles totaled up to. In quadrilaterals, all the angles, we add angles 1 plus angle 2 plus angle 3 plus angle 4, that's going to total 360 degrees. So when we classify the shapes, it's not the same as what we did with triangles because we're dealing with another additional angle in the quadrilaterals. I also want to review this term here, parallel. You're going to see that a lot when we talk about quadrilaterals because we're going to be looking at the sides to see if they're parallel or not. Parallel means the lines or the sides will never intersect. Another word for intersect is that they will never cross and they will never touch. And you will see some examples of that shortly. And always remember, go by the angles and the measurements, not the picture. The picture may be deceiving and not true for what the question's asking you. Let's look at the textbook page. We're going to look at how many pairs of opposite sides are parallel. There's our vocabulary word we just went over. Which sides have equal lengths? We looked at that with triangles too. And how many right angles there are. And we reviewed that as well, and it was similar in triangles. It's going to still be that box that's going to represent 90 degrees. So let's look at some shapes. Here's a trapezoid. It has one pair of parallel sides. So parallel, our vocabulary word again, means those sides are never going to intersect, they're never going to cross, they're never going to touch. The parallel sides in the first shape are here and here. So if I extend these sides out, they will go on forever and ever and ever, and they will never touch. That's not true of the other two sides. If I were to continue with this side going up and then this side going up, they would actually cross right here. So those are not parallel sides. The other two sides are the parallel sides. Similarly, in the next shape, this side and this side are parallel because if I extend them out, they'll go on forever and ever. If I extend the other two sides out, they're going to end up crossing and they intersect there. So those are not parallel. In the second trapezoid, we also have some important markings inside of it. We have those two squares. And remember, when we see the squares, that means it is a 90-degree angle. Let's look at a rectangle. A rectangle has 4 right angles. There are those squares again. So you have 4 present in each of the figures. What's different with the rectangle from what we're going to talk about next, the square, the sides do not need to be the same measurements. So when we look at this rectangle here, I can see that these two sides are the same length, but then these two sides are different lengths. So that is going to mean that that is a rectangle. When we look at the square has all sides the same length. That's a big difference between the square and the rectangle. The square must have all 4 sides the same. So this side, this side, this side, and this side are going to all be equal in measurement. Here's a parallelogram. Parallelogram has 2 pairs of opposite sides that are parallel and equal in length. So I have this side and this side are parallel and it's the same measurement. This side and this side are parallel and they're the same measurement. This figure that's over here in the middle, it doesn't have 90-degree angles, which is not a requirement of a parallelogram, but this side and this side is parallel. This side and this side is parallel in the figure to the right. The opposite sides are parallel and equal in length. That's true of all the sides. So for the last shape, let's look at. I have my 2 parallel sides here. these are the other sides that are also parallel and equal in length. A rhombus has all sides the same length, and we don't have to necessarily have that 90 degree. You may be looking at this shape and be like, hey, that's a diamond. Diamond's not a shape that we classify by in quadrilaterals. So anytime you see diamond, you have to start thinking rhombus. Rhombus has all the same lengths of sides. So this side, this side, this side, and this side, they are all the same. Same thing with this middle figure. And finally, with our square, you may recognize as well, but the square is special because it also has those 90-degree angles. So a square can be a rhombus. Here, like we mentioned earlier, just so I can mark the notes as well, below the square, we had a square has 4 right angles, and we talked about those boxes showing those 90-degree right angles. Let's look at the convince me. How is a parallelogram different from a rhombus? Okay, so let's go back in our definition. I'm going to erase it so we can see better. So parallelogram. It has 2 pairs of opposite sides that are parallel and equal in length. So 2 pairs of opposite sides that are parallel and same length. Okay, so let's see. So 2 pairs of opposite sides are parallel and same length. My rhombus has all sides the same length. Okay, so all sides same length. So how are they different? Okay, so all sides the same length. The parallelogram has opposite sides parallel and are equal in length. Okay, so the big difference between the parallelogram and the rhombus is that the parallelogram can have 1 pair of opposite sides the same length. They don't have to have all the sides the same length. So a good example to give you a visual is if I look at this figure right here in parallelogram, and I look at this figure here in rhombus. Notice the difference. If you look at the parallelogram blue figure, you would think of something like a rectangle because the opposite sides are the same length in parallel. This side and this side are the same length, but they're not all the same length. A rhombus has all sides the same length, and that would be what we also call a square. So that's the biggest difference, is that in a parallelogram, they do not have to all be the same length, but the opposite sides do need to be parallel. Let's look at some more worked examples. The red circles are the ones I'm going to work with you. Each time Sophie makes a cut to a polygon, she can make a new type of polygon. What kind of polygon is left if Sophie cuts off the top of the isosceles triangle shown? So a polygon is another term for shape. So let's see, Sophie gave us the cut. Let's cut this off. It's gone, okay? So now I'm left with this shape. It has a flat top, down the side. Okay, so what shape is that? This is going to be a trapezoid. I have those 2 sets of parallel sides, and I have the other set that will intersect. Look back to the previous page for additional notes to help you compare and complete these questions if you have to. Is it possible to draw a quadrilateral that is not a rectangle but has at least 1 right angle? Yes, you can. And if you look at your notes, there's one that's drawn in the examples for you. We have a shape that looks like this. And it actually has 2 90-degree angles in it. This shape is also another way to draw a trapezoid. It has the 2 sides that are parallel, like we just talked about, and then the other sides will intersect, and it actually has 2 right angles. So both of these questions, the answer is trapezoid. This is number 11, and then this is number 13. Let's look at 17 and 18. Which quadrilateral could have side lengths 1 meter, 5 meter, 1 meter, 5 meter? Okay, so let's draw that out. Let's see, 1 meter by 5 meters by 1 meter by 5 meters. Okay, so what's that shape look like? I have the opposite sides are the same length. The opposite sides are the same length. So these are also 90-degree angles. This is going to be a rectangle. So square, no, because all sides need to be the same in a square. This would be rectangle. Trapezoid, no, because I would have lines intersecting. These, I have opposite sides are parallel. So no trapezoid. Rhombus, the opposite sides are different lengths, so it can't be a rhombus. All the sides have to be the same length. So my final answer for 17 is rectangle. This is number 17 drawing. 18. Which of the following statements is not true? All right, not true. A rectangle is also a parallelogram. Well, we just drew a rectangle, so can it be a parallelogram by definition? Yes, it can, because opposite sides, I'll draw another rectangle here, opposite sides are equal in length and they're parallel. Opposite sides are equal in length and they are parallel. So that statement's actually true. So goodbye, A. B. A trapezoid is also a quadrilateral. Well, I drew trapezoids earlier, and I'm classifying quadrilaterals, and quadrilaterals have 4 sides. So my trapezoid, 1, 2, 3, 4, has 4 sides. So a trapezoid is a quadrilateral. Goodbye, B. A rhombus is also a rectangle. I'll draw a rhombus you're familiar with. Remember, we don't use diamond, but diamond is a rhombus. So a rhombus is also a rectangle. A rhombus has to have all the sides equal. Well, I just drew a rectangle and all the sides are not equal, so that's not true. Oh, I'm looking for not true. So my correct answer is going to be C. Let's just make sure that I didn't make a mistake. A square is also a rectangle. Well, we talked about squares. They have 4 90-degree angles, and all sides are the same length. A square is also a rectangle. We drew a rectangle. That's not true because rectangles have opposite sides that are the same length and parallel, while the square has all sides the same length and opposite sides are parallel.